In today's video, I would like to talk about something different a little bit instead of a charge controller, lithium or whatever, but it's already part of it. It's a family, it's a thing that's associated with the one old off-grid or grid-tied solar system or battery backup system or AC coupling system. You need one of the key things with monitor your batteries, which is called the battery monitor. The battery monitor comes in different manufacturers and different form of shape or whatever. But what I have here today is an OutBack FLEXNet DC. The FNDC is normally called FNDC, short abbreviation for it, which is responsible for the state of charge for your battery. Guys, you guys been seeing a lot of stuff with I have solar, I have different machines, but the thing is, my OutBack, like I promised last year, I'm gonna make sure I incorporate everything that's gonna go with the OutBack, because I want to build a solid OutBack system and all the rest of my systems. Guys, well, this is what I have here. We're talking about the FNDC, which is a FLEXNet DC, which is responsible for state of charge of your batteries. So see the health, how healthy your batteries are, how properly your batteries charge, what comes in, what goes out from your battery, discharging, and cutoff thing, set up your voltage, your parameters, and everything. This little guy here is responsible to do everything like that, incorporated with a charge controller and solar panels as well, including the batteries. They work hand in hand. They are brothers and sisters. They are co-friends. They are comrade, or they are pal, mate. So, guys, before going further, I would like to show you how to install, or what is needed to install a OutBack FLEXNet DC, or how to install a FNDC. Today, this is one of the machines I have here. I'm going to show you the things that you need, or you have to have for you to install a FNDC. You need a tool, okay? You need an OutBack hub, okay? This is it has 4 channels here, okay? It's 5 total. I'll talk about it. Okay. These are all family here. They have to work hand in hand. They have to work together for everything to work properly with the batteries. The tools are here. Okay. If I can zoom out a little bit. Tools are here. Set them on the corner. Very important. Okay. And we need a network cable if you want to use this guy and this guy to communicate. All right. And we need communication wires as well, which is responsible for connecting these batteries to give them power, or to monitor the sensing the current, that power that goes in and out from the battery. And this guy is going to be reading it, and the charge controller understand it, and it's going to regulate the charge. Okay, so we need this connector, like an adapter, that goes on the side here, where these cables have to get connected here on the corner. I'll set it aside here. And you need a sticker that, if you install this guy in the other way around, that looks like this, you can bolt it somewhere coming from like this PVC. You cut that size right there, a size like this and sticks out, you can screw this thing in. You're only gonna see these things you see here. There's 5 things, indicators. It's a light indicator that tells you the percentage of your battery, what's remaining, or if the batteries are full. So if you decide to go that way, this one's supposed to be inside, or this one is inside the box, then you need this guy here to paste it on the side to tell you, just a guide. This is a reference guide for you to know what light or whatever, what it means, or what that light meant, and you can able to take a proper action towards whatever you are doing. So guys, last but not the least, you need a shunt. Okay, this is a device that is responsible to measure voltage and current that comes out from in and out of your batteries to monitor what's going on or the health of your 1-volt battery bank. If you look at it keenly, if I try to get these lights properly aligned, you will see what I'm trying to talk about here. There we go. You will see a 500 amp here, and you will see a 50 millivolt. Okay, this side is the responsible where you're gonna tie the battery to your battery bank. The cable that comes from your battery bank, okay, it goes in here first. This is like the security. This is the main gateway. Comes in here, and this side here is the side that register to show you how much power has been taken or is taken from your battery to any of your device. If you turn a light bulb, you put any load, even your inverter is on standby, your charge controller is on standby, anything that happens, this guy is the main guy that attacks, or that is the guy that always monitor everything, that everything has to work or should register, or you have to cross-check with this guy first before you do anything to keep the batteries alert. Say, hey, this is what is coming. You point power back to the batteries. You have to tie your charge controllers, or you charging with your inverter charger. You still have to tie from this end here, which is from the 50 millivolt. Okay, 50 millivolt. There you go, 50 millivolt, and it's reversing back to here. So the power goes this way, reads this way, and reads that way. Your load is going to be on the 50 millivolts here. Okay, 50 millivolt. There we go. The 50 millivolts to the 500 amp. So on this other side here, this is where we're going to tie the sense cables, which these cables right here I was talking about. And when you install this device, the solid wire is always acting like the positive wire. Okay? And this one's going to be like the negative. If you switch it, you're going to see on the back here is a 550 millivolt. So you connect the wire, the solid wire that goes to this guy. So it goes like this. The one with the white and orange has to be on the something like this. Okay, when you flip it over, it's gonna be like this. The 50 millivolt is here with the white and orange, and this one gonna be on the other side. So this system can take 3 of this. Okay, 3 of these shunt. You don't need that, but if you have to for your application, whatever you want to apply for or whatever you want to use this device for, you need 3 of these. This system, okay, let me take that back. This system can handle, that's the word. This system can handle 3 of these shunt, because you look at it here, it's going to tell you, okay, shunt A, shunt B, shunt C. So you can have solar, wind, or hydro, or you can have solar, two wind turbines. So they're all going to be seeing, this guy is going to be seeing these devices like separately instead of combining them, like just see what amps, so you can know what the solar is doing, what the other wind turbine is doing, what this other wind turbine is doing. So, or you can use this device for other reasons, or maybe any other source, or hydro, or whatever you want to use on these guys here. This side here is the battery. There comes this guy, this little guy, that makes the job easy. You plug this in. Remember, there is a little notch right here. It's going to correspond with here. There is it. So you plug these guys here. This helps you to put these wires in place. Okay? You have all these wires here. The end part of it is this side. Let's say you want to use the B. Okay? They're already color coded. I can use this one. Say this side here is going to be my wind turbine. Okay? Plug it on this side here. These two terminals here. And that's how you end up using this guy here with a little tool. Take the smallest one, a flat, right there in the center, this one. And you can use it. You always use the proper tool for, or the right tool for the right operation. And goes to this. So this gives you a good understanding. You know that your orange and white gonna be your wind turbine, or the green and white is gonna be your solar, and the blue and white, which goes here, is a color coordination or color coordinate. You know, you can coordinate the colors right here. It's easier. The blue, let me say, is going to be my hydro power or something else, or maybe another wind turbine or whatever. Maybe you have solar array, 2 or 3 solar arrays you want to monitor, maybe a ground mount or whatever. I can able to do this. If I don't have wind, I can able to do that. I can able to monitor each array, how much power that is making, or I'm gonna see it all on the guy, which is the mate. It's gonna show. That's gonna be a next video. So, doing so, there comes this wire right here, which is the communication wire, which is a Ethernet cable, a Cat 5 or Cat 6, whatever you have. It's gonna plug right from the output right there. You plug this one, make sure there's a notch right here that's supposed to correspond with those copper thing there. If you look at this, there's a little copper fins right there, and plug it. It's in. And take this other end of it and plug it. Remember, here the light is shining, but the mate goes on the first one here, and the second one, which is number 1 on channel 1, you can see channel 1. Okay, 1 2 3. It's gonna be your inverter first. Your inverter goes in here first. That's how it sends through the mate. Don't install the inverter at the back. It has to go the mate, which is here, the mate, the inverter, and other devices. There comes the hub. Okay, plug the hub here. It's going to be my charge controller number 1, or charge controller number 2, or if you happen to have 2 inverters, you got a mate, inverter 1, inverter 2, and hub and charge controller. They also make this one in 10 channels, which is they can take up to 10. You see, there was a mark they already put there before this one. This is the first generation, and they knew that, or they know that they're gonna be doing something of this in the future to extend. Like people normally have like a lot of charge controllers, a lot of devices, maybe 5 inverters and 5 charge controllers. There's just a massive system, like a mini grid, and they can able to incorporate all this on one of these guy. This is the guy that communicate with them, and you see it's all tied up now, and this is how they communicate. Okay, this is how they communicate. So guys, this is the one old install about the FNDC. If you haven't seen one before, I know you you already did, or you have, but I just want to give you how a good explanation, if it's gonna help you on your future projects. This is what you need for the one old thing, like just like having other battery monitors, but this guy can able to take 3 of these. That's what I was saying. You can have array, solar array number 1, number 2, number 3, or maybe solar array number 1, number 2. Maybe this one is facing south, southwest, or maybe north or south, and this is gonna be your wind turbine. So maybe you have 2 wind turbines here with a solar system, or solar, wind turbine, or hydro, or solar, array 1, array 2, or solar, hydro, and wind. So everything just left to you, whatever you want to do, and you can able to do anything with this guy with the help of one device here, which is called, keep dropping this thing, which is called the mate. Okay, the mate can take care of all this work, or all these things already compiled to talk to each other and do the work and monitor everything. Stay tuned. So when we talk about things work hand in hand or work together, this is the Mate 3. They have the latest one with the Mate 3S. And this Mate, I was telling you earlier, it has a communication port right here. It's an Ethernet. You see, this goes to the hub. Like I was saying earlier, it connects to the hub right on this hole, the first one here. Okay, that's why it connects. It says the hub right here. You can see it. See that hub? This one goes to the Ethernet for your optics RE. So this is how they plugged in, which I'll probably demonstrate again, show you. Here is the other communication wire, and it's gonna plug behind here that says hub device. Plug on this one. You have the other end right here, and where it's gonna go, remember where it's gonna go, it's gonna go right here where it says hub for the mate. See, it's gonna say mate right there. Sorry for the glare, but you're gonna see it right there. It goes right there. So all these guys already plug in together, and they tend to talk, or they tend to do things simultaneously. Everything, all the readings from the FNDC, and it's gonna be registered with the help of this guy that regulates the power, monitor what comes in and comes out. This one is watching if the batteries are getting full. This one is the one taking care of the communication, and this is the main brain telling them, the command center, or the operator, or the drill sergeant is going to tell you what to do. And everything's going to be displaying here. And one of the buttons here, I think the middle one, is going to say the shunt. You can go shunt 1, shunt 2, shunt 3, and select which device you want to see how they perform, or what's going on with them, how many amps, how many kilowatts, how many amps they generated, and all the good stuff. So it's connected. This other side goes to your router, and get the optics RE, so you can see just like any Ethernet port, like your computer or whatever, your device, Blu-ray. They have a game station. They have these lights gonna be blinking back and forth or fluctuating, telling you the device is already in progress. So guys, these are all the devices, like I said, we need to set up our FNDC, which is this guy here, FLEXNet DC, made by OutBack Power at www.outbackpower.com. So you can see exactly, and you can even incorporate it. It says a 5 amp at 30 volt DC relay. You see that? So remember, when you connect here, the main side there, almost about to skip that, is the battery side. Make sure you have the positive and the negative. This one ties to your power, to your, not on the shunt right here. It ties to your power that comes in, your positive and negative. Somewhere you can attach it to your bus bars or somewhere, and that's the one that feeds the power to this. That powers this guy here. And make sure the positive side here, see, a positive has to have a inline fuse. A fuse supposed to be here, because it's better for you to be safe than to be sorry. You blow up this guy, it costs you a lot of money. It costs a lot of money. You look it up and see how much it costs. You don't want to mess with it. It's a good asset right here, investment. So make sure you have a fuse on the positive side, an inline fuse. Okay? All right, this wrap up our video, and I know this video is getting long, but subscribe, like, and share. See you on the next video. Thank you. Bye-bye.